This is the start of our second quiz material. So each time we start a new quiz, a little mini unit, I guess, you need to get to the correct, so you'll see this to start with, and then you're just going to tap on quiz 2, and it'll take you to quiz 2. You need to make sure, if I can't copy it off, and who knows, with shortages the way they are, I'm probably not going to be able to make copies. I hope I am, but these notes and reference materials, you need to at least print that off so that you can have that handy. Okay, so we are in the first assignment here, which is the first video and the first assignment that you see there. You're going to need technology to help you, because we're going to have to find the roots, the rational roots to be exact, of quadratics, or polynomials for that matter. And there's two ways, with a graphing calculator and online. So let me just show you online to start with. So you'll see this roots calculator video and the roots calculator site. So you're just going to go there and you're going to put in whatever particular quadratic you're dealing with. So I'll put the first one on our very first little lesson here. This first little lesson, I'm going to do the whole thing, so it's kind of just notes. And so you probably want to start on the second one after you see enough of this. Oop, x squared, not x to the 8th, plus 8x plus 12. And you need to learn that factoring is related to, then you're going to calculate the roots. Okay, come on here. Come on. Be cooperative. Okay, there it is. I just had it sitting for a long time. So negative 6 and 2 are the two. And I'm going to write that down. And so the concept of factoring is based on rational roots, or you can do the guess and check way. Get that out of there. Factoring by sight, we'll call it. Either way, I like the roots way because that's like, it's solid. It absolutely 100% tells you what's going on. But here's the overall technique. So this is on the graphing calculators right here. This I call it polysimul 2. So one of three things is going to happen. And this is all linked to that page of notes we had in the last unit with the pictures of the graphs. So imaginary roots means that the graph has no x-intercepts and that there's no factoring. You write prime. Irrational roots, those were the problems where we had to use that funny formula. We got long decimals for the x-intercepts. And then rational roots, which can be integers or fractions. And then we have to check for a common factor. So that's kind of what all of this is saying. We can take it to higher levels other than quadratics, but we're going to apply this to quadratics over and over and over and over, so that you become a factoring genius. So here's the relationship between the roots and the factors. So if you have some type of x-intercept like this, roots means x-intercepts, by the way, 5 halves. You build the factor like this, 2x minus 5. Not x minus 5 halves. Oh, that's going to make me mad. It does every year. You don't do that. But here it appears that you do that. But it's still really, the denominator here is 1, so that does get multiplied by x, and then the opposite sign, minus 3. So this 2 gets multiplied by x, and then the opposite sign from the numerator. Another way to check it is like setting them equal to 0 and solving for x. That produces, when you go forward, the x-intercepts. But we're going to go backwards. We're going to take the x-intercepts and we're going to build the factors. And then we're going to check for a common factor every time. And you really don't need these notes after a while. You're just going to know how to do this. All right, so -6 and 2. And you can use that online root finder. I'm going to show you in here under your apps key. And if you don't have this app, I'll have to give it to you. The school calculators have this on there. It's called PLY-SMLT2, and it might be farther down on your list. So you might have to scroll down. There might be a lot of stuff on your calculator. But anyway, we're going to get to this main menu. And then we're going to pick one, Poly Root Finder. Orders 2, that means that the highest exponent is a squared. So if it was a cube, we would put 3, so on and so forth. And all the rest of the settings don't much matter. And we're going to go to Next, and we're going to put the values of A, B, and C in. A, B, and C. Sometimes B is 0, sometimes C is 0. And then solve. And it will give you the roots, the X-Intercepts. And then if you need to go back to the coefficients, you go here and clear. And then you put your next set in. 1, -4, -12. 6, -2. So the idea is, before you do any factoring, you need to find the X-Intercepts, either by using this app. Okay, so we'll start again here. Apps, PLY-SMLT2, Poly Simul 2, I call it. And we're going to use option 2 later on, so don't forget this. There it is. Next, you put in your A, B, and C, and you hit solve, and you got it. Pretty easy. Then back to coefficients. That is a root finder, just as the one online is. So I'm going to go down and just write in all the X-Intercepts here. Of course, there's 2, or 1, or none, and sometimes they're not very nice. These ones aren't very nice, so I had to round these. So when I get to ones that are goofy, I will remind you where we are in the goofiness. In the red, we're here. Okay, those ones I just wrote down. -2 and 6, -2 and 2. So we're getting these with using this. And I want to show number 6 on here, just so you get an idea of what these weird ones look like here. So you see these long decimals. And I forgot to mention this button over here will convert it to a fraction. No dice. Okay, that means that we're going to have prime for factoring. And we'll get to the graph in a minute. The other one that presents difficulties is 11. This would be one with no X-Intercepts when you're looking at the no real roots found. Or it might give you, if you're in, so your mode, you want to make sure, okay, I guess it's the other one. Let me start this back up again here. So in our mode here, oh yeah, stay on real right here before you get, and then that'll, if you don't, you're going to get some weird roots, imaginary roots with an I. I'll show you that just so. All right, let me go back to mode here. If we were over here, when we do this, you'll get this, like these weird outprints with an I at the end. Those are imaginary roots. That's what this is talking about right here. So keep your mode in real when you do this. Let's go see what the online calculator does with this, just so I can cover this. X squared plus X plus 5 equals 0. Make sure you put equals 0. Looks like it wants to freeze up on me here. Oh yeah. All right, so my computer just froze up on that. It does print out the eyes at the bottom here. So it's probably good to use a graphing calculator when doing this, and to keep it the mode in real so you don't get that, you get the no real roots found, meaning no x-intercepts. So there are all our roots. Be real careful when you enter A, B, and C on some of these. So 170 would be number 10, and 8 would be 10, -4. Just be real careful. So how does the factoring then go? So the hard part is getting the roots. So it's opposite in sign, and it's the denominator times x, opposite sign, and then the numerator. Well, most of these are just integers, so it's going to appear just to be opposite. But you're really multiplying the denominator, which is 1 in every case, times x, and then opposite sign, and then the number. So like -3/2, that would be 2x plus 3. And a lot of times what I do is just put a little x in the bottom like that. So this one would be 4x plus 9. Of course, I'm skipping around. I've got a little bit of attention deficit here. I'm doing my work. X minus 5. Now, one thing I want to say that I haven't talked about, this is how you write the factoring. So how in the world does, oops, somehow I messed that up. These should be both negative here. And that's exactly where I was going to. So how in the world does this factoring give us this quadratic back? And the answer is you do something called the FOIL product, which I'll do number 5, the FOIL product. So you take these 4 products, first 2, outer 2, inner 2, last 2, and as you do that, it should deliver back to you, adding the O and the I step together. And so when we add the -12 plus 9, that gives us -3. When we do that entire product, it delivers back, and upon combining the O and the I, the original problem. So that's ultimately how you check your work. And you do need to, in a quiz environment, check your work. Another thing I haven't been saying is you need to check for a common factor also. I have not been doing that. It's going to be wrong if I get it wrong. So what I mean is the first 2, so when I do 4x times x here, that's 4x squared. That's what I got. So I know 4 is not a common factor. But down here are my x-intercepts. So when I do x times x, that's x squared. But it's 2x squared. But this is right, according to the rules of factoring. So there must be a common factor of a 2 in front. And so if you initially took a 2 out, you have this, and then you could also run that through. It doesn't matter which one you run through, it would deliver that factoring. So make sure you check for a common factor. People always forget that. I forget that. Notice here, you got to have 2 of these to make it work with the FOIL product, which I would hope you have some remembrance of. Now, one thing I want to say, 0 is x all the time, and then x plus 7. Okay, so there's no factoring here, prime, either way, however you want to write that. That's factoring. Okay, so when is it prime? When you get no real roots, no x-intercepts at all, or your x-intercepts are irrationals, kind of like those long decimals we got on the last set of practice quizzes. And then you match the x-intercepts up, so -6, -2. That matches C. So on and so forth. And this is really pretty simple to do. You just need to watch enough, of these videos so that you can easily factor. And the bigger thing is the technology. Can you use technology to find roots? Literally, you can just type this in an internet search, and up is going to come the x-intercepts and probably some factoring along with it. Although I'm going to warn you, online factoring sucks. Some of these algorithms, it probably would get these right, but some of the common factor ones and some of these, it actually factors incorrectly. So you need to listen to this, not get so reliant upon online engines all the time. Another way to do these is to guess and check. You know, you got the FOIL product, and so you're looking at a number that multiplies the 12, and then when you do the outer plus the inner products, you get 8. Well, I can just think of that. So not all the time do you need to use technology. But on number 5, yup. So knowing when to use technology is really important. Okay, and I'll end this video right now.